In this video, you will learn how to name ionic compounds. So nomenclature is the language of chemistry. So you really need to master this chapter with naming and writing compounds, because this is what you're going to use for the rest of your scientific career. Now you need to be able to speak this language. Okay, so we're going to start off with naming ionic compounds. So we're going to have the metal and the nonmetal, the metal and the nonmetal, and that's what we're going to focus on. Okay, so here is a flow chart of what we're going to learn how to name. Okay, so like I said, we're going to start off naming ionic compounds, then we'll go over naming molecular compounds, and finally we'll discuss acids and bases, but acids have a naming system for themselves. Okay, so let's start over here on the ionic compounds. Okay, so the first thing you always need to do is to figure out if you have an ionic compound versus molecular versus acid. So remember, if it's ionic, you're going to see the metal and the non-metal. And just again, a review, the blue is the metal, and over here are your non-metals, and we're looking for that combination. Okay, so following this arrow, it says your cation has only one charge. This is referring to the fixed ions. So remember, the ones that are fixed are group 1, group 2, aluminum, zinc, cadmium, and silver, right? And ammonium also, which is a polyatomic ion. Okay. So those are the fixed charges. So what you're going to do is you're going to name the metal or ammonium first. If the monatomic anion, if you have a monatomic anion, you'll end it in "ide." And if you have a polyatomic anion, you just use the name of that polyatomic ion. Okay, so here are some examples. Let's just write them a little bigger. They're kind of small there. So if we had MgBr2, okay, you would name your cation, which is magnesium. And then it's a monatomic anion, so then you would write bromide. And over here we have sodium nitrate. Okay, so you write your metal, cation first. Okay. Sodium always is a +1 charge, and then your anion is a polyatomic ion, so you simply write the name of that polyatomic ion, which is nitrate, so sodium nitrate. Okay, now let's go over the other type of ionic compound, and this is when your cation can have more than one charge. So that means everything else, which is all these other metals here in blue. So those are your transition elements, or some under here, under the metalloid line. Okay. So they're going to need a Roman numeral so that we know the charge of that ion. So you're going to name your metal first, just like before, but you need to use a Roman numeral to specify the charge. Okay. So the charge you're going to have to figure out based upon your anion. So you always, let me repeat that, you always have to know the charge of your anion, right? By using your periodic table or knowing your polyatomic ions. Okay, so let's write these examples a little larger. Okay, so to name this compound, we have to know the charge of the bromide. And the formula shows me that I have 2 bromides, and I know it's a halogen, therefore it is a -1. So I have a 2 minus, right, for the anion side, and I know that must be balanced by a 2 plus, because that's how it's written. So my 1 iron is carrying the 2 plus. All right. And so it is this 2 plus that means Roman numeral 2. So that. So when I write the name iron, Roman numeral 2, bromide, the Roman numeral tells me the charge of my metal. Okay, so let's do another example. I'm actually going to erase this for some more room. Okay. All right, so let's do the second example here. Okay, so again, the formula shows that I have 1 nitrate, which is, you have to know that, it's a -1. And I know that I have 1 nickel, right? Because there's no subscripts there. So that has to carry the 1 plus. So I know that must be 1 plus. And therefore, this charge, right, will show up in the name as the Roman numeral 1. So it is nickel 1 nitrate. Okay, so remember, if your metal is not group 1, group 2, aluminum, zinc, cadmium, or silver, or ammonium, it's going to need a Roman numeral, so we know the charge. And the charge must be determined from your anion. Right, let's do some practice. Okay, so again, you should pause the video, try these first, and then go over the answers with me. Okay, so A, we have metal and we have a polyatomic ion. Calcium is group 2. It's always 2 plus, so we're just going to write calcium. Phosphate, right, is your anion. It's polyatomic ion, so just write its name. So calcium phosphate. Okay, now we see we have iron. Iron is a transition metal. It's not one of the fixed charges. So we're going to do what we did before, and it's a good idea to maybe make these charts until you're good at it. Okay, so the formula tells me I have 3 bromides. I know that bromides are -1 because they are halogens, so that's 3 minus. I have iron, I only have 1, so it has to carry the full 3 plus charge, and that is my Roman numeral, right, 3. So the name is iron 3 bromide. Okay. Next one, we have aluminum, always 3 plus. And now I have a monatomic anion, which is sulfur, so it becomes sulfide. So I write aluminum. Did I spell that right? Aluminum, I'll just do sulfide. Okay. Remember, ending in IDE. Okay, IDE. This one's a polyatomic ion. Okay. Now we have zinc. And now although zinc is a transition metal, remember it's one of those fixed charges. So it's always 2 plus. So I don't need the Roman numeral. So I could just write zinc. And this is NO2. So 1 less oxygen than nitrate. So that one is nitrite. And then the last one here, we have sodium. And you need to recognize that HCO3 is bicarbonate or hydrogen carbonate. And so we write sodium, let's use bicarbonate. Okay. And one last one here. What is the name of the following compound? Okay. So we have our metal, which is cobalt, and we have dihydrogen phosphate. Okay, so cobalt is a transition metal. We have to know the charge of our anion side. Right? So phosphate is 3 minus, but we have 2 H's, so it's a 1 minus. So 1 minus has to be balanced by 1 plus. Therefore, cobalt is cobalt 1. Oops, I almost forgot the dihydrogen. Okay, so this is a long name. Okay, so cobalt 1 dihydrogen phosphate.